Hey guys, today I want to talk to you about Lewis dot structures. And the document that I had you print is actually one of the coolest ways to do Lewis dot structures. And so basically, you just have to remember that except for hydrogen, whoops, let me get a pen, except for hydrogen, the octet rule is going to say that each atom needs to have 8 valence electrons to fill its outer shell, okay? And covalent compounds are going to share electrons. So they may have single, double, or triple bonds. Sorry about the ad, but I can't get rid of the ad. So these bonds are going to be represented in a Lewis structure, right? And you've seen Lewis structures before in honors chemistry. But this is kind of a interesting way to draw Lewis structures, and it really helps as far as resonance structures go and calculating formal charges and things that we'll have to kind of do. So if you kind of go through, they're going to use silicon dioxide. So SO2 is our example, okay? Silicon dioxide is used as an example. So we determine which atom is the central atom, and it is usually the least electronegative element, that is not hydrogen. And then you draw a skeleton structure that shows the minimum number of covalent bonds needed. So Si will be in the middle, and there's an oxygen on each side. Now, 3 and 4 is kind of the interesting part to this then. Number 3 says, determine the total number of electrons required for each element to have an octet. Well, except for hydrogen, everybody needs 8. Oxygen needs 8, silicon needs 8, and the other oxygen needs 8. So there are 3 atoms that need 8 electrons, and so there are 24 required electrons. So that's the first part that we do. Then, on a second line, we're going to determine the total number of valence electrons present. And if there's a charge, and we'll do some examples of that, if there's a charge, if it's a negative charge, we'll add another electron to that number. If there's a positive charge, we'll take an electron away. And then 5 says, determine the number of covalent bonds. As a guideline, subtract the number of available electrons from the required, and then add additional bonds. So again, reading through this, you're like, yeah, okay. So what I want to do is I'm going to close out of this, and I'm going to bring up some notes, and then actually Word document, sorry, and work some problems, and kind of seeing this work, I think will really help you put it into play. And so your worksheet that you've downloaded is going to have some problems, but I want to do some samples, okay? Like, let's say we have CH4, and CH4 may even be on your paper. Nope, it's not. Okay, so with this method, we first start with electrons required. So carbon needs 8 electrons to be happy, and each hydrogen needs 2. So our electrons required are 8 for the carbon, and then each hydrogen needs 2, but we have 4 hydrogens. So 4 times 2 is 8 and 8. So 16 required electrons. Now we're going to look at valence electrons that everyone brings to the table. Carbon brings 4 valence electrons to the table. Each hydrogen brings 1 valence electron, and there are 4 hydrogens. So that's 4 valence electrons. So 4 plus 4 is 8. I'm now going to take the 16 minus the 8, and I'm going to get 8. I'm going to divide that by 2 because there are 2 electrons in every single bond, and 8 divided by 2 is 4. So from that, I know that I have to have 4 bonds in my Lewis structure. So we'll take carbon and we'll surround it with the 4 hydrogens. And carbon has a full octet. Each hydrogen only needs 2. The last thing we should do is double check our number of electrons involved in bonds and outside of any elements. So we have 2 electrons here, 2, 4, 6, 8, and that matches our 8 here. Let's do another one. Let's do water, okay? Let's do H2O. Good old H2O, hydrogen. Let's see, we have oxygen. Oxygen needs 8 electrons, and each hydrogen needs 2, and there's 2 hydrogens, so 2 times 2 is 4. So 8, that's 12. We're counting for 12 electrons. Valence electron speaking, oxygen has 6. Each hydrogen has 1, and there are 2 hydrogens. So 6 plus 2 is 8. So 12 minus 8 is 4. If we divide that by 2, we're going to have 2 bonds. And so we'll put our oxygen in the middle. We'll do our hydrogen. And then we have to make sure we fill the octet for oxygen. So there's 2 electrons here. There's 2 electrons here. We need 2 more to complete the octet for oxygen. And so if we add up our electrons, then we have 2, 4, 6, 8, and that matches our 8. Let's keep going for examples. Let me find something. Let's do an ion. Let's do NO3 minus. Okay? All right, NO3 minus. Nitrogen needs 8 electrons and oxygen, because we don't have any hydrogens here, so we have 4 things that need 8 electrons if they're involved in bonds. So 8 times 4, we're talking about 32 required electrons. All right, looking at valence electrons. Nitrogen has 5. Each oxygen has 6, and we have 3 oxygens. And we have an extra electron because we have a charge. All right, so that is 18, and 5 is 23, plus another one is 24. All right, 32 minus 24 is 8. So that's 8 electrons divided by 2 equals 4. I need 4 bonds. So nitrogen is our least electronegative element. If I attach an oxygen to each, now I only have 3 bonds. So I'm going to add a 4th bond to one of the oxygens. We'll talk about resonance in the next lecture, but I'm going to pick this one. You could have picked the bottom one. You could have picked the right one. It doesn't matter. So now let's check, everyone. Nitrogen looks like it has 8 electrons around it, but the oxygens are lacking in a big way. So we're going to add them. And then here, 2, 4, I only need 4 more. Okay, if it is an ion, we put it in brackets, and we put the charge outside. Now, I want to count all the electrons around and make sure I get 24. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I am in great shape, okay? So that is my electron structure for NO3 minus. We can, let me delete that draft and bring up another one, and we'll do a couple more examples, and then you can, we'll talk a little bit about formal charge, okay? All right, let's do PCl4, PCl4 plus. All right, there are 5 elements present that need 8 electrons if they're involved in covalent bonding. So 5 times 8 is 40 electrons. Valence electron speaking, let's see. Phosphorus has 5 valence electrons. Each chlorine has 7 valence electrons, and there's 4 of those. And then we have a positive charge, so we're going to take one of those away. And so 7 times 4 is 28, and 5 is 33, minus 1 is 32 electrons. So 40 minus 32, 8 electrons divided by 2, we need 4 bonds. Phosphorus is definitely my least electronegative element. Okay, I think we're good. So now I'm going to count and I should get 32 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Yay, we have 32 electrons. And so this is our Lewis structure for PCl4+. I do want to go back to, actually, I'm going to stop here and tell you, let me go back to the PDF if I can. Whoops, here we go. For your homework, for today, I want you to skip, skip number 7 and skip number 9. But leave the space for them because I want to go back to them because we want to talk about calculating formal charge, but we're going to do that in our next lecture. So complete problems 1 through 6, and then do the structure for number 8 and do the structure for number 10. And if you have any questions, feel free to contact me via Teams if necessary, or email me. Thanks, guys.